and B of mass MA and MB respectively are kept in contact on a frictionless table. So suppose on a frictionless table, these two objects are kept in contact. So suppose this is a frictionless table and these two objects are kept in contact. MA and MB are kept in contact on a frictionless table. The experimenter pushes the block A from behind so that blocks accelerate. So this is like this. Suppose this is A and this is B, and the experimenter pushes the force from behind like this so that blocks accelerate. If block A exerts force F on block B, so F external force is applied and the A exerts a force F on B. So this internal force, the force between these two, is F. So here F is acting, it is given. The A exerts a force F on block B. What is the force exerted by experimenter on A? So this is the thing we have to find. This force is not given, so this one we have to find, the experimenter force. So here also we can write the different forces. So how do we write different forces? If we write the different forces here, there will be MAG downward, then there will be normal NA upward, then there is a external force, this, and since A is exerting force F on B, the B will also exert a force F on A. So if we make free body diagram for A, so why do we make free body diagram? Because the forces are clearly visible. Because in the diagram it may not be visible, so we make it separate diagram. So MAG, then NA normal, then experimenter force, then the internal force F. So this is the condition of forces on A. Now here we will also write for B. First we can solve this. See, in vertical direction system is not moving. So NA equal to MAG. So this we can write. This are balanced along vertical. Along vertical. So this is the equation along vertical. So we can take X and Y axis like this. X is horizontal, Y is vertical. And next we will write horizontal equation. So along horizontal the acceleration could be there because the forces are acting. So suppose acceleration of the system is A. So both will have same acceleration because they both are in contact. So F experimenter minus F internal, the F force, will be equal to MA. This is for object A along horizontal. Along horizontal. So you can write it like this. So this is the equation we are getting. Now the same thing we are going to do for object B. So if you see for object B, we have a force F and a normal NB and a downward weight MBG. So the free body diagram will be F, normal NB and downward MBG. So NB must be equal to MBG. Why? Because along Y direction or along vertical direction, no acceleration is there along vertical. And along horizontal, if we write, only one force F is there. So F equal to MB. This will be MA. This is MA. Here it will be MBA. A is common for both because they are in contact. So we are getting this thing. Now what we are asked? We are asked to find this F extra. This thing we need to find. So for this, F is given in the question. A is not given. So what we are going to do is we will find the A from here. That is F by MB. And this A we can put in this expression. So we can write F external minus F equal to MA. And at place of A we can write F by MB. So if we solve it, we are going to get F external equal to capital F plus MA by MB into F. So if you simplify, you can write it like this: 1 plus MA by MB. So in this way we can find the value of external force.